Hi everyone and welcome. In this video, I will be doing a lesson on translation using vectors. Now, translation is one of several methods of transformation that can be applied. The question that we're given is pre-image coordinates A, -4, 2, B, -6, -4, and C, -2, -4. We're going to translate this image that is formed from these coordinates using the vector 4, 6, where 4 is, of course, our x value and 6 is our y value. The pre-image represents the object before translation or any form of transformation actually takes place. So what we're going to do here is that in order to derive what the question is asking us here for, which is to use a table to record the new coordinates, which are the coordinates of the image, and sketch the graph showing the translation. When we do a translation, what happens is that we shift an object in some direction. It could be horizontally, rightwards or leftwards, or vertically upwards or downwards. So we're going to carry out a translation here using the given vector. 4 represents our x value and 6 represents our y value. So to carry out this transformation, what we're going to do is to add the x value in the vector, and this vector is in component form, which is in coordinate form. We're going to add this x value from the vector to the x values in each of these pre-image points, pre-image coordinates, and we're going to add the y value from the vector to each of the y values in the pre-image coordinates. So A prime, which represents the image of A, is going to be found by adding 4 from the vector here to -4, which is the x value in A. 4 plus -4, of course, gives us 0. Then to get the y value for A prime, we add 6 to 2, and 6 plus 2 here gives us 8. And then, in order to derive the coordinates for B prime, which represents the image of B, what we're going to do here is that we're going to add the x values in the vector, x value in the vector, to the x value in B, which is -6. Remember, all the first values here are x values, and the second values to which they are mapped are y values. So for B prime, we will derive the x value for B prime, which is the first value in the coordinate pair, by adding 4 to -6, which is going to give us -2. Then we add the 6 here from the vector to -4 in B, and 6 plus -4 is going to give us +2. And so to find C prime, we're going to use a similar method. We're going to add 4 from the vector to -2, which is the x value from C. 4 plus -2, of course, gives us 2. And then 6 from the vector to -4 from C, which is the y value in C. And 6 plus -4 is going to give us, 6 plus -4 is going to give us a +2. So the image for C, which is C prime, is 2, 2. So we have developed all the coordinates of the image under this vector translation 4, 6. And what we're going to do now is to sketch the graph to show this translation. But before we sketch the graph, we can go straight ahead and actually write the transformation rule. The transformation rule here is typically written in this form: xy from the pre-image, meaning the x and y values from the pre-image, have been translated by adding 4 to the x values based on the information we're given in the vector here. It's translated by adding 4 to the x values and also adding 6 to the y values. So this is the rule under which this translation is taking place. So we call this statement here the rule of transformation. All right, we should say rule of transformation, or we could say rule of translation. Either is fine, because specifically the type of transformation that we're doing here is a translation. So the rule of translation here is xy, meaning the x and y coordinates from the pre-image have been translated on the vector x of 4 and y of 6, which means that we added 4 to x and to the x values in the pre-image, and we added 6 to the y values in the pre-image. And so that's how we derive the rule for this particular transformation. Now we're going to go about sketching the graph here. So I'm going to just draw some lines to represent the information that we need. So let's consider this to be our 0 point right here. Upwards from that, I'm going to put 2 on the y-axis, 4, 6, and 8. And let's just draw our horizontal line here. Just a sketch, of course. And this horizontal line is showing our x-axis. And then I'm going to draw a line coming through this to represent our y-axis. So this is our y-axis, freehand drawing, and this is my x-axis. So below the 0 point here, I'm going to put a value of -2 here. I'm going to put -4 here. I'm going by 2's. And I'm going to put -6 here. And I'm going to put -8 here. Values below 0 vertically are of course negative, and to the right of 0 we're going by 2 again, so 2, 4, 6, and then we're going to go as far as 8. And to the left of 0 our values are going to be negative, so I'm going to have here -2, so -2, then 2 spaces further we're going to have -4. And of course, we're going to have -6, and further out, we're going to have -8. So this is my y-axis. We're just drawing a scale here that can easily fit, and this is my x-axis. We're drawing a scale that can easily fit the coordinates that we have. So now I'm going to plot the coordinates of the pre-image first, starting with -4, 2. So -4 here on the x-axis, going up to 2 on the y, and that is the coordinate for A. Then I have here -6. I have -6 here on the x-axis, and this -6 on the x-axis is going down to -4 on the y, and I'm going to call that B. And then I also have -2 here on the x-axis, going down to -4 on the y, and that's my coordinate C. Then I connect these points and I realize that we form a triangle. So the object is a triangle. Now we're going to sketch the image of this triangle. The image of this triangle again was formed under the vector translation of adding 4 to the x values in the pre-image and adding 6 to the y values also in the pre-image. So here are the coordinates of the image that we came up with. I'm going to do that in a different color. So let's use nice blue. So 0 to 8 is going to be A prime. That's A prime. And B prime is 2 to 2. Yes, this is B prime right here. And C prime, this would be C prime. 2 to 2 would be C prime. Yeah, that's C prime right there. 2 to 2. 2 to 2, 2 on the x to 2 on the y, that's C prime, and B prime is -2 to 2. So that's B prime right there. And then we realize that a triangle is also formed here, and the triangle represents the same size and also the same angles of the pre-image. And it means that this vector translation that we have carried out here using the given vector is a rigid transformation. It's a rigid transformation because the image preserves the same size and also the same angles as the pre-image. I'm going to draw one line connecting either A to A prime or B to B prime or C to B or C to C prime, showing the vector that was used to carry out the transformation. So I can either draw a vector from A to A prime or B to B prime or C to C prime, showing the direction of transformation and also the magnitude of the transformation. So I'm going to connect here A to A prime, or you could have connected B to B prime or C to C prime as I said. So here I'm going to do A to A prime right there, and I'm going to use an arrowhead to show the direction of the transformation, and I'm going to write the vector here, V, and V represents the vector here, which was used to carry out the transformation of the image, the pre-image ABC to the image A prime, B prime, C prime. So this vector is characterized by having a direction. The direction is from the pre-image to the image, and it also has magnitude, which is a distance from A to A prime, which is the same distance from B to B prime, and also from C to C prime under the common translation vector of 4 to 6. So that completes this problem. We have successfully here used a vector to derive the image from a given set of pre-image coordinates. We have written the rule of transformation that was used to carry out that translation, and then we have actually graphed the translation and indicated the vector connecting A to A prime, or we could have connected B to B prime or C to C prime. But the critical thing is that the vector that is drawn shows the direction of translation, which is from the pre-image to the image, and it also shows the magnitude or distance between each point and the corresponding point formed in the image. Thank you very much, everyone. I hope that this was a lesson in learning how to use vectors to carry out translation. Thank you. See you soon.